All right, this topic is operations with complex numbers. Just as you can represent real numbers graphically with points on a number line, you can also represent complex number in a coordinate plane. The complex plane is a set of coordinate axes in which the horizontal axis represents the real numbers and the vertical axis represents the imaginary numbers. So you can go ahead and see on the graph to the right, the traditional x-axis is your real axis, and your vertical axis is your imaginary axis. So when we have complex numbers in a plus bi, the real part is the a and the imaginary part is the b. So when we graph, we have the real axis corresponding to the x, the imaginary axis represents the y. So we're going to go ahead and graph some of these complex numbers. So we'll start with 2 minus 3i. So what we do is we go to the right 2 on the real axis and then down 3 on the imaginary axis. So right 2, down 3. And then we just label that point A. For B, the complex number is -1 plus 4i. So that means we're going to go left 1 on the real axis and then up +4 on the imaginary axis, and there's point B. C, the complex number 4 plus 5i. So we go to the right, +4 on the real axis, and then up 1 on the imaginary axis. So that's point C. And then D. Notice that one does not have the real part, so I'm going to go ahead and adjust that to, when I graph it, 0 minus 1i. So when we graph this, we do not move on the real axis, and then we go down 1 on the imaginary axis. So that is point D. Recall that the absolute value of a real number is the distance from 0 on the real axis, which is also on the number line. Similarly, the absolute value of an imaginary number is the distance from 0 along the imaginary. So there's an example here that shows you a complex number graphed out. So this is the equation we're going to use. So I'm just going to circle that. So you have an absolute value of a plus bi. What we do is we take the square root of the real part and square it plus the imaginary part squared. And then there's an example off to the right that shows you the 3 squared and the 4 squared. You add them together and you get 5. And then what they did is they graphed it. So here's the origin 0, 0. And they graphed the complex number. So you go right 3 and up 4, and there's that complex number. And that distance from the origin to that green dot is a distance of 5 units. So example 2 says find each absolute value. So we're going to be going ahead and using the green equation that I circled up here. So what we do is we identify the a value, which is 3, and we square it. We identify the b value, which is 5, and we square it. We simplify underneath the radical, so we square the 3, which is 9. We square the 25, or 5, which is 25. And then what we do is we just go ahead and add those numbers together to give you the square root of 34. You do not need to enter that into your calculator and simplify it any further. Exact form is fine for us. All right, example B. Notice that it's missing the imaginary piece. So it would be like this, -3 plus 0i. So then when we find the absolute value, we only have to actually square the real piece because the imaginary is 0. So -13 times 13 is a +169. Now 169 is a perfect square, so the square root of 169 is 13. The last example is missing the imaginary, or the real piece, so 0 minus 7i. So that's what it looks like when I put in the real piece. So when we take the absolute value of it, we only have to worry about the imaginary part. So negative 7 times negative 7 is a positive 49. 49 is also a perfect square, so square root of 49 is 7. So again, the purpose to this is we could find the distance from the origin, 0, 0, to the point, the complex point, and what that distance is. Example 3. Add or subtract the complex numbers and then put the answer in standard form, which is complex form a plus bi. So this is a complex number, and this is a complex number, and what we're doing is we're adding the two complex numbers together. So what I'm going to do is going to go ahead and drop the addition symbol. So we have plus, and then negative 6 minus 7i. So think of these as like terms. So we have the real piece and the real piece. So I'm going to just go ahead and group those together. And then I have the imaginary piece and the imaginary piece. I'm going to group those together as they are the like terms. And then we simplify. So 4 minus 6 is negative 2. And then 2i plus 7i is negative 5i. So what the result is just a new complex number. The second example now has a complex number and another complex number, but be very careful. That operation between them is a subtraction sign. So we do need to distribute essentially that negative into both of those terms. So we're going to change the signs when we drop it. So the first complex number, we just drop the parentheses. And then the second complex number, we have to change those signs. So now it's going to be a positive 2 and then a positive 3i. And then we group our like terms. So we have the real pieces 5 and 2. And then we have the imaginary pieces of negative 2i and 3i. Those are our like terms. So 5 plus 2 is 7, and then negative 2i plus 3i is a positive 1i, or 7 plus I. Example 4, we're going to be moving on to multiplication. You can multiply complex numbers by using the distributive property. If you see an I squared, you're going to replace that with negative 1. So if you see an I squared, replace it with negative 1. So here's our first example. We're going to multiply these two complex numbers together. So we're essentially just distributing that 2i into that binomial. So negative 2i times 2 is negative 4i. And then negative 2i times negative 4i is positive 8i squared. And then when I highlight up there in the pink, notice that I squared is going to become negative 1. So that I squared is negative 1. And then we simplify. 8 times negative 1 is negative 8. And then we do need it to be in our standard form of a plus bi. So we will need to change the order. So I have my real piece first, then my imaginary piece. All right, second example. We're multiplying these two complex numbers together. So think of this as distributed. We're going to FOIL. So 3 times 6, or 3 times 4 is 12. Then we're going to go to outside. 3 times negative I is negative 3i. Then we go to inside. 6i times 4 is 24i. And then we go to last. 6i times negative I is negative 6I squared. Now we do have like parts, like terms essentially, and we're going to go ahead and combine those together to give you 21I. And then notice here's our I squared. So you're going to replace that with a negative 1. All right, so I'm going to bring everything else down. So 12 minus, and then 6. All right, so 12 minus 21I, and now negative 6 times negative 1 is positive 6. And then again, we have like terms. We have the 12 and the 6 become 18 minus 21I. Again, we want to make sure it's in standard form. So we have A plus BI, A plus BI, or if there's subtraction. So that's standard form.